All right, we are going to look at a Hooke's Law example problem in motion along a single plane. This problem reads, Hawkeye's son pulls a small car on a flat floor by a 50 Newton per meter spring. If the spring is pulling on the toy purely horizontally and it extends by 16 centimeters when pulling the 900-gram car, what is the acceleration of the car? And we're going to ignore friction in this case. All right, so the object that we're interested in, of course, is that car. So the first step in our force analysis process is looking at forces, trying to find that acceleration based on those forces. So let's draw a picture of the scenario. Here's our car that's being pulled along by a spring along that floor. And we're told that the stretch in the spring is 16 centimeters, so 0.16 meters stretch of that spring. And the spring constant for that spring is 50 newtons per meter. And we're told the mass of the car is 900 grams, or so 0.9 kilograms. All right, so next step in the process is to look at the forces acting on this car and drawing a free body diagram. So let's look at the forces. We know that the force of gravity exists. That's between the car and the earth. And that, of course, acts in the downward direction equal to mg. The car's interacting with the floor, so we know that there's that normal force of interaction purely by it sitting on this flat horizontal surface. And we, of course, have the spring pulling the car. So we have the force of the spring, which is between the car and the spring. And that's it. No other forces are acting on the car. We're told to ignore friction in this problem. Okay, so we're going to number these forces and then break them up into their horizontal and vertical components. Okay, so force number 1 is only acting vertically, and it's acting in the downward direction, so we're going to put that negative in there. Force number 2 is acting to the right, so it's positive, and we know that our force of the spring is K delta X, and it's not acting in the vertical direction. And force number 3 is only acting vertically, and it is indeed positive. Okay, the next step is to sum our forces. So in the horizontal direction, we have K delta X, and in the vertical direction, we have N minus mg. And if we apply Newton's second law, we know that the sum of the forces horizontally and the sum of the forces vertically are represented by those sums. Vertically, we're not changing our direction we're not changing our motion in the vertical direction, so those forces are 0. Horizontally, we are changing our motion, so these forces are equal to the mass times the acceleration in the horizontal direction. Now, we're interested in that acceleration, so this is what we're going to go after. Dividing both sides by m will give us that acceleration horizontally. And so we are given that k is 50, delta x is 0.16, divided by the mass of 0.9, and our acceleration on this situation divided by 0.9 is 8.9 meters per second squared. So a quick zip as Hawkeye's son pulls on that car. All right, so recognizing the object, recognizing that Hooke's law is going to apply. Here's where that Hooke's law is coming into play for us because of the spring. We're identifying the direction that spring is acting explicitly in our list. And then, of course, recognizing which direction the change in motion is happening and solving for the variable we're interested in. All right, good job.